We want to look at graphing the inequality in problem number 2, 4x plus 5y greater than or equal to 12. The directions tell us to use the intercept method to make this graph, but we've focused on slope-intercept method, so I want to continue that here. In order to get this inequality into slope-intercept form, I need to solve for y. So I'll subtract 4x from both sides of my inequality. And I have 5y is greater than or equal to negative 4x plus 12. And then I'll divide both sides of my equation by 5. Remember, instead of equation, this is an inequality. And that makes a big difference because if my coefficient of y had been negative, we know that when we divide both sides of an inequality by a negative number, we have to reverse the inequality. That is not the case in this problem, but an important thing to note. So my inequality is y is greater than negative 4/5 x plus 12/5. We want to graph this now. So there are a couple of things I want to point out. Because this is in slope-intercept form, we can start at our y-intercept, which is 12/5. If you're not sure what that is, you can divide 12/5, and you'll find out that that's 2.5. I'm sorry, not 2.5, 2. It'll be 2 2/5, which is 2.4, so just a little bit less than 2.5. And then my slope is negative 4/5. That means I have to go down 4 and over 5. Well, again, this is challenging because I'm starting at 2.4, and I have to go down 4. 1, 2, 3, 4. And then I have to go over 5. 1, 2, 3, 4, 5. And as we've been saying, graphing is going to be one of our least precise techniques because we cannot accurately draw or very precisely draw anything. If I had a ruler, I could definitely make this even more accurate, but I'm just going to sketch in this line as best as I can. And I want to point out that I'm using a solid line. The reason I'm using a solid line is because my inequality has or equal to. If that or equal to was not there, this line would need to be dotted. The next step to graphing our inequality, after we've drawn the boundary line, is to determine if our ordered pairs lie in the solution set or not. My suggestion to you is to always check 0, 0. So take the point 0, 0 and plug it in for x and y. So if I take y is greater than or equal to negative 4/5 x plus 12, and I plug in 0 for y and 0 for x, I'm trying to algebraically determine if this inequality is true. Negative 4/5 times 0 is just 0, and 0 plus 12 is 12. Is it true that 0 is greater than 12? If you had $0, is that more than having $12? No. So this ordered pair 0, 0 is not in the solution set for this inequality. And if you remember what we did yesterday in class, all of the points that were n's were not part of our solution set. And that means that everything on the other side of my line is going to be a solution. Now, I could certainly double check that. I could pick any random point in this shaded region, and I could algebraically check what I just did here, and we should be able to come up with a true statement for any point in this region. Instead of having to check lots and lots of points, we only need to check one point. My recommendation is to always try 0, 0 because the arithmetic with 0, 0 is fairly easy. However, if the line goes through 0, 0, you cannot check using 0, 0. You have to choose a point that is not on the boundary line, but in most cases, 0, 0 will work.